Hey there, geometry students. Happy Wednesday. Since we did not have our asynchronous Monday, we're going to do a quick little lesson on finding area, and then you'll have the rest of the period to start working on your homework. So, Unit 8 is our new unit. We are officially done with Unit 7 on right triangles, and we're now going to focus on finding area. But what you'll see in this lesson is that a lot of the concepts that we saw in our previous unit are going to come up as background skills that we'll use to solve our area problems. So some vocab, area, right, as well as square units. So that kind of goes nicely with this picture of a rectangle. So finding the area of a rectangle is finding out how much space is encompassed in this shape, right? And specifically, when we do that, we do our length times our width. So 8 times 6, that'll get you 48. And then what you typically write is units squared. So keep that in mind. 8 is a unit. For length units, it might be centimeters or inches. So for instance, if this was inches, let's pretend it's inches. Our answer would be 48 inches squared, or square inches. And that's just a differentiation between the length of something. So you use just inches to say how long something is. And then we use square inches to indicate that this is an area rather than a length. So that's kind of the thought process behind the differing terminology there. Okay. So keep in mind we're going to review some of the older area formulas that we've used in the past. So that's our rectangle, right? Length times width. So you can maybe make a note. Length times width. Some people will do b times h, which is your base times your height. Right? Either of those interpretations, length times width or base times height, are fine. What you'll see is after we look at a couple shapes, there's some area formulas, so we'll record them at the very end as well and review them together. The next one is a parallelogram, and this is one that you probably haven't seen before. So what I'm going to do is I'm going to grab this link, and it's going to show us an animation to help us see the formula. So here's the animation. Here is our parallelogram. Notice we're kind of cutting off that corner and moving it. And it'll play again. We're cutting off that triangle on the edge. We're sliding it. Notice we create a rectangle. So we're just cutting off that little triangle and scooching it to the other side. So what you can infer from that then, if we take this triangle, right, I'm going to kind of do a different color. It's taking this triangle and moving it over, right? We're kind of cutting it off and scooching it along. We then create a rectangle with a base of 8, or you might call that a length. That's fine too, however you want to describe it, and a height of 5. So then your area is just the same as a rectangle, 8 times 5, and that's going to get you 40. Let's call these centimeters, just to have something different. 40 centimeters squared. And if there's not a unit, you can just say units squared or square units. So I like this one a lot because it builds nicely off of our rectangle. So this is a nice little addendum with the parallelogram. You can also kind of imagine the parallelogram straightening up. That's also another visual that some students like, where the sides, these two sides become straight up and down rather than slanted. And then the next one we're going to see, last one, is our triangle. And triangle is a little bit harder for students sometimes. We're going to look at the animation for this one, and I think it's going to make a lot of sense when you see the animation. So here is the animation. I'm going to refresh it. Here we go. So if you take this triangle and you duplicate it, and you take the duplicate and turn it around to kind of fit in like a puzzle piece, notice when you put it down there, the two triangles make a parallelogram. And I'll show one more time just to see it a second time. And the area of one triangle then is half of the area of the parallelogram. So the parallelogram is the base times the height like we just saw. So a triangle's area is taking that and then dividing it by 2. So it'll show that one more time just for reference. Take the triangle, duplicate it, turn it around to kind of fit in like a puzzle piece. And you're going to make a parallelogram. and the two triangles make a parallelogram, and we just talked about the area formula for a parallelogram, right? We know it's going to be half of the total, so the parallelogram is base times height, so we just do that times 1/2 or divided by 2. So let's write that down formally. Okay. So we just kind of saw, I'm going to draw it in here. So it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There we go. So here's my identical triangle, right? Kind of the flip side there. I know the parallelogram. I'll write it out. Area is base times height, right? But I only want half of it. So you can either do base times height divided by 2 for the area of the triangle. And I'll kind of like point out that that's just the parallelogram right there. And then we divide by 2 to get the triangle. You can also do area for the triangle as 1/2 times base times height. Timesing by 1/2 is the same as dividing by 2. Okay, so let's write those formulas down. So we saw the formula for our rectangle, and I'm going to kind of label base and height. Area equals base times height. Now notice I wrote my base up top. Some students have trouble seeing the base if it's not labeled on the very bottom. But remember, we can turn these shapes around. It's the same as like the length versus the width, right? So I can call the top the base or this bottom part the base here. Either of those work. And then I want to do my parallelogram. Okay, so here's the parallelogram. And remember what we did was we snipped this part off, placed it over here, and we saw that it was the same thing. It was base times height. Feel free to add a picture if that helps you kind of see it out. So we've got the base times height. And the triangle is right above, so I'm just going to kind of look right above for my visual there. So I'm going to draw my visual. I'm going to duplicate that here. So area equals, we've got the base times height, and then remember we want to divide by 2 because we only want the 1/2, right? Not both. And we can also write that as 1/2 times base times height. What you'll see is you're kind of more used to, from previous grades, writing area as length times width. It's a little bit more common in high school to write base times height. But either way, I'll know what you mean if you write it in a slightly different format. Okay, so these are really great and they build off of each other in a really nice way. One thing I also want to point out briefly is that this year, due to some of the difficulties of squeezing everything in with the new format of learning online and not meeting as often as we normally would, I'm just going to point out a couple of shapes that we normally look at for area. Are kites. I'll draw my kite here. And these are cut this year. So a kite as well as a rhombus. Remember, a rhombus is a parallelogram where all sides are equal, right? So one of or two shapes that we normally look at finding the area of are these. And we don't have enough time this year. One strategy that you could, if you needed to, find the area of these, just to kind of expose you guys to them, is finding the area of the triangles. And what's kind of cool is that these triangles are identical for the kite, as are these. So if you find the area of one, you can double. For the rhombus, all of these triangles are actually identical, which is really, really nice. And that's just because of coming from the fact that all the sides are equal. So those are a couple shapes that we don't quite have enough time for, but one strategy you could use if you're ever introduced to finding the area of either of these in the future is breaking them down into triangles. If you look online, there are also a couple of other formulas that you can utilize, but this is probably one of the nicest strategies. It's just treating them like a couple of 4 triangles each and putting the areas together. So just wanted to mention that before moving on so you knew that we were not having enough time to cover those couple of areas. And then what you guys see here, this is your homework. So I'm going to kind of mention a couple things about it in this video. And what's kind of nice is you've got your square, your rectangle, your parallelogram, and your triangle. Just a quick note for your square area, instead of your rectangle is base times height, Remember a square, all four sides are equal. So if I call this like I'm just going to call this my base, for instance. You could call the area base times base or base squared. Some people, in addition, will instead of a B use S for side. So some people, depending on where you see it written, will just say area equals the side length squared. That's probably the more common, but it's just basically a rectangle base times height, but base and height are the same thing. So just wanted to point that out. And what's really nice is all these problems are asking us to find the area. Well, you'll see for each shape, you'll see an old version, kind of the easier level of what you probably were exposed to in the past. And then in the new version, you guys are going to see the harder version. So whereas before, you would just multiply the sides times each other, right, for a rectangle or a square. That's probably how you were exposed to it in maybe middle elementary school. If you look at the new side, these are harder versions where in order to get the sides, right, I don't know these, but if I use my hint of a special right triangle, I can use the pattern that we saw in Unit 7. Same thing for this one. I don't know one of the sides, but if I use the hint of Pythagorean theorem, I can solve for that missing side. So what you'll see is the area problems we look at have a slight twist to them where they're going to be just a little bit harder than before. Okay, same thing here. We've got one where we're going to have to utilize trig down here. And then this one is a lovely visual where you have to kind of plot the points and think about how far it is between each of the points. So this uses a little bit more visualization. So this is the homework that you guys are going to work on. And if you look at Google Classroom, you'll also see a key so you can double check your answers as you work just to make sure that you're feeling good on the concepts. So that's it for today. I'll see you guys next time.